From the RSNA, this is the Radiology Artificial Intelligence Podcast. My name is Paul Yee, and I'm a radiologist and co-host of the podcast.
And my name is Ali Tejani, and I'm a radiologist and co-host of the podcast. Each month, we dive into the hottest topics in radiology AI and talk with leading experts, thought leaders, and movers and shakers in the field.
Hey, welcome back to the Radiology AI podcast. Today we're joined by Dr. Pranav Rajpurkar, who is an assistant professor at the Harvard University, the Department of Biomedical Informatics. Dr. Rajpurkar has been a key player in many of the foundational discoveries of AI in radiology. His work has been published in some journals you may have heard about before, including Nature, Lancet, and New England Journal of Medicine. He has received a few minor recognitions along the way, including Forbes 30 Under 30 in Science, Innovator Under 35 by MIT Tech Review, Nature Medicine Early Career Researcher to Watch, and the Google Research Scholar Program. But importantly for our topic today on entrepreneurship and radiology, he recently started a company. We're also joined by Dr. Moritz, who is currently an abdominal radiologist at St. Louis University, and whose experience spans both private practice and academic hospital settings, and who recently joined Pranav's team. Welcome.
Thanks for having us today.
Thanks for having us, guys. Great to be here.
One of the things that I wanted to try to do with this podcast is kind of go a little bit of a different direction. I feel like we've had a lot of different people in the different science and aspects, but we haven't really had a deep dive on the other side that other people, careers may travel down in the world of radiology, and that's the entrepreneurship route. I think it's something that not a lot of people experience, whether it be from starting their own company or working for a startup. And so I thought you two would be perfect to bring on the podcast, talk a little bit more about your experience. So I know you've done a lot of foundational work in the field of radiology. Dr. Rajpurkar, seems like you recently started a new company, and I was really interested in what was your motivation that made you take that leap?
I've been now in the field of AI for about 11 years and in the field of AI for medicine for about 7. And I think once you work on any problem long enough, you sort of get a vision of how things should work versus how things do work. And I think in the process of learning about and contributing to the field of AI for medicine, in particular radiology, I think one thing became obvious is that the way we were developing technology and the value that we needed to deliver were two very, very different paths. And let me just explain what I mean by that. Most of the way we've been thinking about AI projects starts with, I care about a disease. I care about identifying the disease. I care about either some aspect of detection, of diagnosis, or of saying something about the future. I put that under the prognosis category. And then we think, let me identify how to label for that disease, then let me train an AI model to solve for it. And that's great. But then you think about the radiology workflow, and in particular, the task that really boils down to, I need to describe everything that's abnormal about this image, characterize it to the best of my ability, measure when necessary, and ultimately produce this report. And then you think, where does my single model prediction fit into that? Okay, well, we have one model, it does one thing. That's not producing a report. How many such models do I need? And so what you might think at this point is, well, we just need a lot of models. And, let's go out and label for every disease and let's go build a model. And that's initially what we did. Initially, we thought, hey, look, we've got a ton of diseases. Let's go and build for each one of those. But then you run into these errors and these scenarios where it's essentially clear that the right way of doing things, the right way of solving the problem, is to think about one model that can try to do it all. And people get scared by that idea. It's like, what does doing it all mean? Does this mean CT and ultrasound and MR and X-ray? It's like, well, no, let's take it a step at a time. Let's first ask the question, can we have a single model that can just detect a lot of diseases on a single modality. And so that's the sort of work that we started doing it with self-supervised learning, which was how to learn without labels, multimodal learning, which was how to learn jointly from these images that have these reports associated with them. And that sort of built, I would say, a trajectory, a blueprint for how we actually go to the task people care about, which is I need to look at an image, I need to describe everything that's going on here that's relevant. And about October 2023 or so, it became clear to me that this blueprint could work at scale and just needed efforts in terms of saying this was going to work and this has to be done with a conviction that this is the way to do things. Now, this can be done as a research effort, and we've done a lot of that. But I felt deeply that this had to be done in a way that would eventually provide value to people who had this problem on a daily basis and who feels the pain. The pain is felt by the radiologist who suddenly has 20 more scans to read in a day with the same number of hours to read them in. It's felt by the referring physicians who now have to have a response to their query and their imaging within a short turnaround time. So the whole system is starting to feel this burden. And we're seeing that and hearing that across the country, especially in areas where the demand and the supply just don't match. And so that became thesis of what became the company A to Z Radiology AI. And just fun fact about the name, it sort of stemmed from this idea of, well, to make something useful, you need to detect everything from A to Z. And so it became natural to start to think about, well, how do we, one, build, but then how do we bring this technology out and really entrepreneurship as a vehicle for doing so with the right priorities and the right goals in mind.
That's amazing. And I think very well thought out and also said. You had mentioned that back in 2023, it became obvious to you, more or less, that this could work. Was it like a particular result, or is that just seeing a lot of other people make this gradual result towards this thing to where you just had the intuition that this would work after many fails and successes of your own? Love to hear your thoughts on that.
We had this effort in my academic lab called MedVersa. The idea with MedVersa wasn't specific to radiology. It stemmed with the following scientific question, which is could you have a single model that looked at different kinds of medical images, different kinds of clinical questions that somebody could have, and as part of the same training process, as part of the same architecture, solve all those problems simultaneously? And not tasks that you have pre-trained the model to be able to solve. It's not, I've trained the model to identify nodules, so it's going to identify nodules. No, the idea was you could specify in natural language using a sentence, I care about identifying this. Can you do this task for me? And have the model be able to do that with medical data. We know this can be done with ChatGPT for general kinds of tasks, but how do we feed in a medical image? And people have these demos that they share online of trying out Gemini or trying out Grok and saying, oh, look, it doesn't work. Well, yeah, it doesn't work because that's not what it's been focused on. But what would it look like if you actually did focus on having that kind of medical data work with these generalist AI models? And so that was really the tipping point in my mind for a technology where all bets were against this approach working. All bets pointed to if you want a really good fracture detection model, build a fracture detection model and don't have the model do anything else. It's like, no, the way you build a great fracture detection model is you train a great model to generate reports and detect fractures and detect nodules and do pathology images and do dermatology images and do chest x-ray images. That was surprising. And that really is the sort of proof point at which you start to ask yourselves, what does this mean about where we're headed in terms of the development of this technology and the scaling of this technology for our field?
I think that's very logical. And especially the results speak for themselves as far as bringing all these domains together. you had mentioned bringing all these different elements in order to train this one model and how much data would probably go into, for example, we all know how expensive ChatGPT was probably when it came to training it. DeepSeek, is kind of turning that on the head a little bit about how much these things might actually cost to create a great model, but especially in the medical sphere where getting good data is incredibly difficult to come by. I'm interested in how you have managed to coordinate all these different people, or as far as doctors, radiologists, other stakeholders as well. Like I know we have here with Dr. Mike Moritz, one of the radiologists that works closely with your startup. Love to hear both of your thoughts on that.
Yeah, so I can kick us off. I think it is true that compute is costly. It's true data is unavailable. And it's also true that I think it's not the most natural things of people who are trained in two different fields to come together to solve a problem. I think all of those are reasons why things should fail in building something useful. But that's where, when you get those three parts right, on the flip side, things can really start to succeed. And so let me start by sort of the third piece of this, which is the collaboration part. And one of the things I have always deeply felt in a field in which, when I started, I knew so little, the field of, AI in medicine, but more generally, medicine, that the most interesting and effective work came out of understanding a workflow and a domain really, really well. And so, as part of this, what we have tried to do and succeeded to a very large extent, certainly within the domain of the company, is to be able to learn and deeply iterate with radiologists who understand not only how a single workflow works, but how things vary across different practices. And I think having an understanding not just of how things are done for me at my place, but more generally is useful. And I'll just say one line from a book I read in my PhD that always stuck with me. It was a book on software engineering, and it said something like, the second system that a programmer designs is the most dangerous one. Because the problem with the second is when you're doing the very first, everything is new. But when you're doing the second, you tend to overgeneralize based on what you learned from the first. And so it's not until the third that you start to really calibrate and understand what true variation looks like. And so that's been the sort of driving force of a lot of our success and work, is having that sort of closed loop between the domain experts on either side of the clinical and the AI.
I think that's right. I think the interesting thing about Pranav, we actually first met in his medical AI boot camp. It's sort of a long, convoluted story, but I was in private practice. I'm an abdominal radiologist. I was in private practice for about 5 years out of fellowship. And I got this opportunity to sort of go back to where I trained and do some AI sort of directorship sort of stuff. And I applied for the medical AI boot camp that Pranav runs through his lab, which is like this group of, I think it was about 50 or 60, active people, more or less, in Slack on there, radiologists from all around the world, literally, from Korea, India, all across the world. And then, these super smart computer science undergrads from Harvard and Stanford. And so, culturally, everyone's interacting and, figuring out how to interact with each other. And, we're providing some clinical sort of supervision, like, hey, this is interesting problem. This is how things work, in the real world. And then they're providing, their own domain expertise. So that was sort of like, I think, perfected, in Pranav's research and then this medical AI bootcamp stuff. And then my involvement with A to Z, sort of grew out of that. I sort of tagged along, for the ride in A to Z. But yeah, it's really that sort of cross domain interaction, I think, that is going to drive, success in these areas, because there's all sorts of problems that, when I got interested in AI, I was watching stuff, trying to learn Python myself. I'm like, I'm never going to be, the world class computer engineer. Maybe you can learn a little bit, maybe you can hack around and do some stuff, but I'm too far along to start doing that. But I do know a lot about, imaging. I do know a lot about different practice patterns. Like I was in independent private practice, which is basically like running a small business. I mean, there's all sorts of, I mean, you guys are aware of like the economics of radiology right now, especially private practice is like very, there's some very serious problems. And so that has its own, unique aspects. Independent private groups have certain perspectives. And then now I'm in a large integrated health system, employed by the health system, but also with an academic affiliation. So that's a whole different, perspective. And I'm sort of seeing the buy side and the sell side of, we're looking at AI algorithms, we have things deployed, I know what the challenges are. I know, like, if you go to someone, you say, hey, like, we have this thing and, we're going to do this integration. They're like, no, there's no way no way that's going to happen. You need to monitor it this way. We're like, no, we don't have the infrastructure, the resources to do these things. So I think there's a certain amount of guidance that, even beyond just the clinical, you know, here's what you need to do for an abdominal pelvic CT. Like, here's the interesting things. Here's the things you need to consider. There's other, sort of healthcare things that, we can also provide as guidance. But yeah, it's really like the, world-class engineers plus, this clinical side that's, rapidly iterating on stuff that I think is going to be, ultimately successful because really it's like, in research, there's all sorts of cool, papers that come out, report generation and foundation models that come out. But at the end of the day, it's going to be what is actually going to drive adoption of this stuff. That's what's actually going to impact patients and make a big difference. And if you can't do that,
Yeah.
and that's our driving goal or our sort of, North Star is like eliminating diagnostic imaging errors. And if people don't adopt whatever you're doing, you're not making a dent in that. So
It's really awesome that y'all been able to create this forum where you can bring together all these people with their different talents to really pursue hard goals and achieve them. And just to, add on to that, I think it's very interesting because it's like we have these very ambitious and worthwhile like models we're talking about that categorizes everything from A to Z. But the way I see it is like there's already so many things we can do with just like simple programming, not even just like these AIs that are already doing like these really awesome things. I think that could really speed us up. But there's just something as like simple as having something that can filter through phone calls for me or other things. It seems like there's this like so much resistance with the healthcare system in general. There's a lot of rules and everything. I think that really stops the implementation of a lot of these things. But going after and trying to understand all the different practice settings and unique struggles of those, I think that's a really worthwhile goal. Ali, I didn't know if you had anything to add on.
I've been enjoying this conversation. I'm kind of just sitting here like a fly on the wall and just absorbing as much as I can. I think it's just so special having both you, Pranav and Mike on because it's that kind of a paradigm, right? You have the science and the technology, you have the means of accomplishing this goal, but you really have to keep your mind to the end user, right? What is it that really matters to them? What's the clinical problem, the novelty that will really make this worthwhile for them? And then how do you even talk about this idea of clinical integration and sustaining this model, right? Over time and across, as for now you mentioned, different practice styles and different when it comes to if we think about reporting, right? The different reporting styles. And then you get into this conversation about imaging informatics and standards. And I think it's just a really nice interaction here, or really a nice dynamic here that makes sense, honestly. Really quickly, though, if you could help our listeners understand. So, what I'm just kind of taking away from our conversation is, we've seen, as you mentioned, talk about going to some of these models like Grok and like Llama, right? Or these multimodal models and submitting an axial image of a CT abdomen pelvis. And we ask, what's the diagnosis? And maybe you see a liver lesion and you have your differential. Like you said, Bernard, right? Maybe we don't have the best success with that sort of approach. But if you go to a separate model, we could call it a fine-tuned model, you have a little more success. Can you tell us more about what foundation models are and what fine-tuned models are? Just a little bit of education for our audience members to really understand the difference between the two approaches there.
Yeah. So I would say that there's sort of a before and after world to imagine. The before world to imagine is what I call narrow models. And narrow models are all about you have one task and one task that's expected for the AI model to solve. So we have a bunch of lung nodule detection on chest X-ray, chest CT algorithms that are out in the market today, a bunch for PE, for intracranial hemorrhage. I would classify them all as the narrow AI. And then what I'd like to make a distinction between is narrow AI and generalist AI. And generalist AI here is talking about the capability. And I'll get to the term foundation model in just a second. But generalist AI, we define as an AI that can solve a lot of different problems. And ideally, a problem that can be specified in language for someone to say, I want to solve this, and have the model solve exactly that problem. Now, foundation models took off, actually coined by one of my co-advisors for my PhD, Percy Liang, with this idea of essentially how we train the foundation model, which is train it to be able to learn something general and solve a lot of different tasks. And so that's really been the main paradigm shift, I would say, at around 2021 or 2022. And that enabled in large part by the ability to communicate in natural language and the ability to really connect that language with other pieces of data, in our case, most relevant images.
Thank you. It's helpful having that approach and that background there. And Mike, like you mentioned, maybe all of us start by learning some more of these details. Maybe we want to start out by making our own model. There's so many times I've talked to individuals who start in this AI space in radiology or in medicine saying, I want to make, maybe not as ambitious as creating a foundation model, but I want to create a detection tool that finds intraparenchymal hemorrhages, right? Start something, I say straightforward, but it's not quite straightforward, but starting with a relatively common use case that we've seen there, or creating a model that detects pulmonary nodules. If you're talking about large language models, creating a model that extracts information from the findings and helps standardize that content. But maybe we experience, Mike, kind of as you mentioned, that boy, it's a great deal of work to learn Python and really to get to that sufficient point of coding to be able to create tools in that capacity. And maybe not everyone's a tool creator. I've noticed though that does sometimes intimidate those who really want to get involved in this space. They sometimes are turned away, thinking that this isn't for me, it's interesting, but maybe I don't have a role here. Now, what I've been saying is that I don't agree with that. I think that each of us comes with this domain expertise. We're there at the front lines. We know what the problems are. We know where the value add is, where those cases are, right? We can help inform teams that, hey, instead of creating a tool that helps me detect rib fractures, right? If we're talking about narrow models, as you mentioned, I need a tool that can detect tension pneumothoraces and then automate reporting of that finding to the clinical team. Like we can start to outline these clinical use cases. But so Mike, in your experience, for those of us who aren't as technical, we aren't destined to create tools, are there roles for us to get involved in the community from that perspective? How does someone starting out find their way in that direction?
I think any radiologist who's interested in this stuff has tremendous potential value to inform an engineering team or any sort of technical experts. And I really don't think they need you to be a technical expert to and just define the scope of the clinical problem and just say, this is my workflow. This is the classification challenge that I have. Or, as Cody was alluding to, maybe there's non-diagnostic issues that can actually be, really important for your workflow, that can save you time and do other things. I mean, I think there's all sorts of directly clinical or operational problems that you can talk to people about and get help. I think the challenge is that different institutions are going to have different, resources available and infrastructure available to do that. And honestly, I think that's the biggest challenge. But yeah, certainly anyone with clinical expertise is going to be valuable for a technical team.
I think our goal as a community should be that no one ever has to build another tool in AI. I think the fact that we are building tools in AI means that we haven't solved the problem generally enough. And this is as true as it is in radiology as it is outside of radiology. So my goal would be to say, what would it take for us to be in a world in which If you wanted to have something that detected tension pneumothorax, you would just say, I now want to detect tension pneumothorax and output the report in the following way. And that was it. That was the construction of the tool. It is the ability for you to translate a idea, a plan in your mind into the execution that in my mind is what programming is all about. And today we have the language of a programming language that, like Python, that allows us to be able to do that in a way that, you know, is trying to speak the language of the computer. Uh, and for the history of programming, it's all about being, how do you take the language of the computer closer to the language of the human? Well, today in 2025, we are getting to the language of the human as the way of communicating with the computer. So the idea that we will need to program in Python, I would like to make the bet that in 2027, no one is going to be programming in Python. We're all going to be programming in the programming language called English, or whatever language that one wants to speak and programming. And I think there is something to be said about understanding a domain in order to be able to be dangerous in it. And as an example of that, um, I want to share sort of one anecdote from a project we were doing in 2018, in which we were interested in getting to the Agatston score on CT scans, and the idea was, could we do it on ungated chest CTs? And people were like, "Whoa, that'd be very impressive if you could do that." The only problem was we needed to actually uh, go ahead and label a ton of these studies to be able to do that. Now, that particular week, all of our radiologist collaborators said, we're busy, but we'll do it next week. They were kind. And one of my students at the time basically said, why don't we do it ourselves? And I was like, how? And they said, well, let's go learn how to do this. And so that week, the three of us, and it's mostly the students, segmented the LMA, the RCA, the LCX, the arteries to be able to come up with that score, and to an extent that it felt like we were able to unlock how to move beyond this bottleneck of not being able to understand what this part looks like. And I encourage more people who are trained in computer science to do that. Sometimes, it's natural to think about this domain as something that's beyond my scope of knowledge. Let me go work with somebody to be able to solve that problem. And in not even understanding the basics of that problem, there's a big lost opportunity. And that lost opportunity may not even be realized by people who don't take the time to at least learn to understand what they don't know. And so, fun fact, for the test set, everything was done by the radiologist on this one, but all of the training set was annotated by computer science, and the model worked. And that was a very proud moment for those of us who spent the weekend and the week labeling for these vessels. So that goes to, I don't know, say something about learning some other domain enough to at least understand the things which should and can be questioned.
I think it's a really great point, and it also goes both ways. Like, just to add my little caveat, like I didn't know how to code 2 years ago. I'd always thought it was something that was very mathy, very technical, and just would be not have enough time. But I gave it a shot, fell in love with it, and I feel like I can do a little bit of things now. But yeah, just don't ever let the intimidation stop you from going after and trying to do bigger and better things.
I encourage people to spend time outside of their comfort zone. So routinely we'll invite and when we talk about imaging informatics, our PACS admin, our technologists, when we're talking about AI teams or data scientists and AI engineers, invite them to the reading room, let them see our workflow. So that way, when we work later in the lab, they have a better understanding of what we need, what our demands are, what our specific guardrails and requirements are. And then we spend time with them to see their workflow to understand how they go about actually achieving this tool, this solution or this goal too. So hopefully we can start seeing more of that getting out of the reading room or getting in the reading room on the other side to spend more time understanding how those processes work in real time, right? As well.
Just to segue back to the entrepreneurship side of things, say you're this person, you just, you have the technical skills, you build this new beautiful model that you want to bring to the world. And one way that you want to do that is you need to get a whole bunch of funding. You need to get people to put it into hospitals and all that stuff. And it seems like a huge aspect of all of this is the people coordination aspect of it, whether it be the investors talking to hospitals, who to hire, co-founders. I was interested in Pranav, how did you navigated that?
I think one of the things that is a necessity is you have to be in love with the problem that you're trying to solve. Because entrepreneurship, like most things which are 0 to 1, is hard. In fact, I'd say, like starting a lab, like starting a company, like starting a family, things can be impossibly hard. And there has to be a driver, a conviction that you feel with every bone of your body to say, I need to do this. Not just that I want to do this, but I need to do this. And that belief that the world has to work this particular way because every other way is suboptimal. And the realization that if I don't do it, this might happen, but it'll happen later, or it'll happen worse, or it'll happen in a way that's ultimately going to be incompatible with the world that I imagine. And so I think this is the single most important factor and probably the most underestimated factor of all. But I can say when one has that, then I feel like when it comes to people coordination, whether that's people that you're trying to hire, people that you're trying to sell to, people that you're trying to get to invest, they can sense your conviction. And certainly when I speak about the problems that I'm trying to solve, I don't know what it is, but I start thinking about them with an excitement that makes me think, like, why haven't we gotten there yet? And this needs to happen. And I think that is contagious. People understand that excitement as I understand other people's excitement to either make the same version of the world come true or in their vision of what that world looks like and should look like. And so I would say, the single most important lesson that I've learned about entrepreneurship is that your conviction has to be rock solid. And even if you're not in love with being the one who solves the problem, you have to be okay with that. But you have to be in love with that the problem has to get solved.
I find that very inspirational. The sense of urgency and just the conviction, like you were saying, to want to create a better world, and particularly with a vision that you have and trying to trying to see it come to fruition, and you're going to try it whether it fails or not, but you're not going to stop from trying it. And so I love hearing that, and I can definitely hear the passion in your voice when you speak about it.
So Pranav and Mike combined here, we have quite a bit of experience, and I think we were already learning so much about what you both have done extensively throughout your careers. And Cody and I can probably attest to the fact that there are many things that we learn along the journey, and we often sometimes continue the right things that we're doing, and maybe sometimes we pivot in a different direction. Are there any lessons that have struck you all over the last few years, over the course of your experience? Any insights that you'll be taking forward the next steps here? Mike, maybe we can start with you. Tell us what you think. What are some takeaways from all of this experience?
Yeah, thanks, Ollie. Yeah, it's definitely been an interesting experience. I mean, it's been sort of a rapid transition from me, sort of breakneck speed from independent private practice to sort of academic, and now entrepreneurial startup mode. Um, But yeah, I mean, I think my big takeaway is just to be open, to new things. I mean, as physicians, as doctors, we're always learning new stuff, especially in radiology. MR didn't exist when a lot of people, came out of training. My dad always, he was a radiologist. He told me, he learned MR out of, journals that came out. Like he just had to learn it out of these, new articles that came out. So I think we just, as a specialty, we have to be open, to new things. And, this new thing is sort of coming down the pike with AI, and, it's just sort of an active learning, open mind, and yeah, just anything that comes your way, just be open to learning and doing new things. And in the startup, it's basically, whatever needs to be done, you got to do it. You don't have like a job description, it's not like, oh, you're the guy who does this. This is what you're going to do every day. It's like we have, this meeting or this, deadline for something. We need someone to, it's like you just do what you have to do. So yeah, that would be my, advice. Again, talking to, clinical people who maybe want to get involved in things, trainees, I've tried to tell our residents, these sorts of things too. Just be open to new things and just continuously learning.
Well, thank you. And then we just have one last question here. This is for both of you, but what excites you? What like really gets you out of bed in the morning?
One of the things that we decided fairly early on, even though we felt like this was not going to be considered by many to be achievable. But on the A to Z website, it says, our goal is to ensure that no disease in radiology is missed. And it's a wild goal in many regards because often we think about let's get to expert level performance with AI. And, here is how we want to solve, not having a pneumothorax that's missed on a chest x ray. Here's how we want to get to not having a PE missed on a CT. And that's sort of been the way we've started to approach this question, but almost think that when we set our goals really, really high, and in this case, saying, no, we need to be at 0 errors, what would it take to get us to 0 errors such that every time we have an image, we are making the right findings, we are making the right workups, we are determining the right effectiveness of therapy. We have a sort of joint understanding of what that world can look like and how we get there every time. The direction of how we get there, sort of, it's been clear that AI is a possible answer. I think over the next couple of years, it'll become clear to the community that we have to go all in on AI to be able to make that a reality. If we think about how we solve this problem at scale, we make a single radiologist better and, less error prone and more accurate and more efficient, it's simply not going to allow us to benefit every patient out in the world. And so how we do that, I think, is going to remain a big challenge for us in the field, and a challenge I think we should hold near and dear because a lot of us work in the field of medicine because we want to do good. And I think, certainly in the way that the oath stands is to do no harm, and having errors is doing harm. And so a world in which no errors are made is a world that I think we can design is within our reach, and it'll take the whole village of radiology to be able to enable that reality to happen, and embrace AI on our way of getting there.
Totally agree with Pranav. The most exciting thing for me, I think right now, we're clearly at the precipice of something just really transformational. I mean, in medicine and society, as a whole, but, definitely in radiology. I had this conversation the other day, or someone said to me, sort of another radiologist in passing, it's like, when do you think they'll be able to, you know, basically generate a report for me and, spit it out and I can just sign off on it? I was thinking, I'm like, we have a lot of the pieces. We are very, very close, not, just in general, we are very, very close to that happening. And, it's going to be a change in mindset from what is out there right now. Everyone sees, the algorithms out there right now, they have value, that's great. But when your intracranial hemorrhage algorithm, the false positive rate is 50% or more. And then for even longer tail, low disease prevalence things, your false positive rate's going to, even if it's 98% specificity, it's still like, 10% or less or something. Like that's a real problem. But when things are going to come out that are so accurate that, like Pranav's saying, you basically trust them. If it's just almost 100% accurate, like that's a total mindset change. And I've seen a few glimpses of those things in different scenarios where, some people call them wow. Nina Kotler has a phrase like wow case, where you're like, wow, like I would have missed that for sure. 9 out of 10 times I would have missed that. And this thing caught it. And we're getting very, very close to the point where that's going to be sort of the baseline for the range of, human disease. I think that's just amazing. And the faster that we can bring that, to fruition, the sooner we're going to help patients, and then we're going to make it available to, everyone across the world, and people who can't afford to have, the expert, UT Southwestern, you can't have the expert, radiologist, subspecialized radiologist read their thing, then they'll have access, to that. So I think that's just incredible and very exciting. So yeah, that's what keeps me going.
I hear a lot of ambitious things that we're definitely going to have to follow on. Hopefully, Pranav, before 2027, but we definitely have to follow up in 2027 to see if we've achieved that goal. So bet's on. We'll see. Agents are pretty high right now. I don't know. Maybe we'll see something in that line of work that gets us closer, but time will tell. And I think even as you're saying, the fact that things would change so quickly in 1 year, 2 years, 3 years, who knows where we'll be. So hopefully we can have a follow-up conversation to see how things are going. Cody, what do you think?
Yeah, I'm super excited for the future. I think people have been talking about AI and radiology for a long time, but I think we're really at an inflection point here. The whole world's eyes are on AI, and I think for good reason. I'm just so happy and excited to be part of this field. Just so excited to see what happens. And then I hope our listeners feel the same way, and that they listen to this podcast and found it as inspiring as I have. So we can all go out there and solve everything everywhere all at once.
Well, thank you again, Pranav and Mike, for being here. It's been an absolute pleasure hosting you on the Radiology AI podcast.
Thanks for having us.
Thanks for having me.
We hope you've enjoyed this episode of the Radiology Artificial Intelligence podcast. Shout out to Yuri Ishimchisen for our podcast music and to the RSNA podcast staff.
Email us at podcasts@rsna.org anytime with questions, feedback, or suggestions.